Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 439. In this episode, Scott talks with Tom Soderstrom from JPL about space and the next IT decade.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I have the pleasure of chatting with Tom Soderstrom. He is the Chief Technology and Innovation Officer at JPL, a division of NASA. How are you, sir?
Very well, thank you, Scott.
What is it like having a NASA.gov email address? Is that just the best?
It is fun. I mean, it's an amazing institution to be part of. And, of course, I'm with the Jet Propulsion Laboratory, which is associated with NASA.
So how does that work? It's associated with NASA. It's not a division of, but you guys are so friends. You're a subdomain of NASA. I know that much.
Yes. So we're our federally funded research center. Mm-hmm. So it's a Caltech contract to NASA that runs JPL. Mm-hmm. We're also a NASA center. We have 30 spacecraft and instruments operating across the universe, at least our solar system. And we also do some non-governmental work. So we get around.
Is it hard to tell where NASA ends and JPL begins?
No, we're very, very good part. We're a NASA center.
I see.
So the NASA work is for NASA, and it's extremely exciting.
Yeah,
I'm bubbling here.
It is amazing. You've got some amazing stuff to talk about, and the way that NASA, as a consumer of NASA products, I like to think about that as myself, has changed. It feels like over the last 5 to 6 years, I'm seeing open source coming out of NASA. We're seeing more images, more data. We're drowning in NASA data when it seemed a little bit more secretive 10, 15 years ago.
I think that's a really good comment, Scott, and I'm glad that you're seeing that, because openness and participation is a really big deal for us. So JPL, we're doing our part, and of course NASA is doing their part. But it's all about getting citizens the value for their buck, and it's about extending humanity and discovering where life came from, and all of those. Sounds like platitudes, but it's much more than that. It's an amazing place to work, and I'm happy to go over some details as we move forward.
Yeah, please. Like when you're in a meeting with bosses and you're a boss yourself, are you saying in those closed door meetings, well, how can we get this information to the people in a way that is digestible, or how can we put this on the website?
Yes, we do that, and we also think, how can we, of course, do things better? What people may not realize is we use the same tools that all you do. Programmers. We use iPhones, we use Androids, we use Microsoft, all the mobile devices, and we use servers. So it's the same technology that we use on the ground. In the space, it's a little different. We have different challenges of radiation and things like that. Jim Rinaldi is my boss at JPL. He's the CIO. We often talked about if we had no legacy, what would we do differently? So think like a startup. And so we've started to do that. And so it's reaching people, but it's also how do we do our business better? And how do we attract the next generation of explorers to come and work at JPL and NASA?
That's so interesting. Like, I can intellectualize that you're saying that you use the same tools that we're using, but it seems like it's such a venerable institution, and that the people at JPL would be just using some magic parallel technology that we the small people don't have access to. But you don't.
No, not at all. And I think the magic of JPL and NASA is very passionate, smart people. Sometimes we use tools that are old. It's an enterprise, and it's hard to bring in new tools in the enterprise. For instance, what we have is we're using things like the approach of IT. I think that's important, and I'll talk about the technology. The approach of IT is not information technology. That's so yesterday. It's about innovating together. Still IT, but it's a very different IT. It's one where you become prosumers, producers and consumers of IT. So we have so many end users that are very smart in IT. They're double deep or triple deep. They're very good at what they do. They're good at IT. And now with the whole cloud and software as a service, we also have to be pseudo lawyers to understand the license agreements and make sure we don't get ourselves or anybody in trouble. But that innovating together drives everything. Mm-hmm. So it's that openness, both inside our institution and also with the public. This is my personal opinion, but crowdsourcing is a very, very big future for us.
Mm-hmm. You know, I've been in the industry 20 plus years, and the first half of that, I had a feeling of them versus us in the sense of I didn't work in IT. I was a consumer of IT, but they were very secretive and very controlling, and they managed their servers, and, you know, we were the dumb users and they were IT. As things innovate in the future, I really like that, innovating together, because it is like a partnership. Whether it be your partnership with legal, you can have an attitude that they're there to say no, or you can have an attitude that they're there to help you say yes. What's the path to yes? It seems like you feel that IT is working in that way as well.
Very much so. And I think as we look at the next IT decade, I'll give you a couple of examples. So we published something that we call Next IT Decade, and it's the next 3 years, because there's a generation gap between a freshman and a senior in college, mm-hmm. and it's speeding up. So the next the last IT decade for us, the last 3 years, were 7 trends. 7 is too much. It's too complicated. So now it's 1 trend. It's social, mobile, analytics, cloud, and something we call key disruptors. So SMAC. Mm. And that part of that, the enabler of all of that, is the C, cloud. Cloud computing made it possible to do innovations much faster. So we've been doing cloud computing for about 6 years now. And we wanted to get in the consumerism, the scale. And so Microsoft, Amazon, Google, that type of scale, but they only worked with the consumers. So we went to our legal team and said, how can we bring these contracts in, not to negotiate every single end user license agreement, but to bring it in so we can have one contract that anybody at JPL can use for each of these vendors. And legal was and IT and especially procurement partnered up and drove this innovation, whereas before it was much more difficult to do. And that can fast forward where we're innovating together all the time now. So legal and procurement is kind of an innovation enabler. Mm-hmm. And when I talk across industry, other industries haven't quite gotten there yet, but they're on their way.
I don't suppose that one can just take the JPL Visa card and the JPL Hotmail account and log into something like Azure.
Yes, you can, essentially. You can't, so what the good news about this, you can't take your own credit card or your own government credit card and do it, because mm-hmm. it's enabled by IT, which means that it's blessed by IT, mm-hmm. which means you won't get yourself in trouble or the institution in trouble, mm-hmm. because we only bless the ones that are safe, etc. Mm-hmm. Now, cloud computing is a big deal, and I could talk about that for hours, and we don't have hours, but the key to us is we use multiple clouds, mm-hmm. and we put the data and the storage and the computing in the appropriate place.
I see.
If you're paying, in the past, we only had one place. Mm-hmm. So if you put all of your computation and storage in the super secret safe, then you're paying too much if it's just a cafeteria menu. And if you put everything where it's not specially secure, then you're not securing your uplink commands and things like that. Mm-hmm. So being able to realize that there are multiple appropriate places and they have a different model, it's been a real enabler.
That's an interesting philosophy. I realize that every vendor wants one to buy into their one vendor world. And a Microsoft person wants you to have an Xbox and a Windows phone and a PC. But I have a PlayStation and an iPhone and a Windows PC, and because that's my hybrid life. Each one has a different role in my life. And from an IT person's perspective, each cloud has good things and bad things about it.
Yeah. If I may give you 2 examples.
Please.
When Azure first came out, we partnered up with somebody named Michelle Viotti at JPL, mm-hmm. and she had the vision of being able to have games where people could be citizen scientists. So we created a website called Be a Martian, and Be a Martian was hosted in Azure when Azure was brand new, mm-hmm. and it was very successful. So as more people logged on, it could automatically scale out without mm-hmm. us having to have computers inside. And that lived on, and was people could participate, identify features on Mars that we could then feed to the scientists that could say 50,000 people think there's a crater.
That.
It's probably a crater.
I remember that. We were exploring tiles of pictures that you had created. It was you were fooling us into doing crowdsourcing work for you.
You got it. So it's very good for the taxpayers' money because it engaged the citizens, it collects data, etc. With Amazon, we've also done a lot. Let me give you one example, which was 2 years ago, a wonderful time, very scary time. It was on the web as 7 minutes of terror. It was actually like, for me, 2 years of terror. And we wanted to share the pictures coming down from Mars with the world.
Maybe explain to a moment for people who are listening who don't know what the 7 minutes of terror were.
It's a wonderful movie created by the outreach side at JPL. And you can Bing it or Google it and look for 7 minutes of terror. It's about a 5-minute video that explains in detail what happens when Curiosity enters the atmosphere of Mars and lands. It goes from thousands of kilometers per second to standstill in 7 minutes. And a lot of innovations were made that had never been done before. So our piece in IT was, how do we tell the story? This is JPL and NASA Super Bowl. It's our Olympics. It's our one chance. We used cloud computing. So as the pictures came down from Mars, we were able to, you saw them at the same time as we did.
Really?
And
you didn't time delay them?
No. And as the time, can you imagine how many people we streamed 150 terabytes in just a few hours? We don't have that type of capacity inside. That would be too much most of the time and not enough that day. So we were able to do content distribution using Amazon's web services. So it scaled up automatically, and we helped it along, monitored it. And then when it was done, it scaled down. And so we only paid for what we used. And it was a really good experience.
That's kind of a classic cloud computing scenario where we need it for a while as a burst, and then we won't need it. So why spend the time building up hardware ourselves?
And we noticed that it was 10 times the volume afterwards as it had been before. So people were interested. Of course, we want to tell the story. An interesting event happened 6 months later, which was the asteroid was coming close to Earth. And some clever person wrote a game that you could ride along the asteroid as it approached Earth. It went viral. People loved it, logged on, and we didn't know. All of a sudden, the guy at JPL was watching the website start spiking, flipped it over to the cloud infrastructure, the Amazon infrastructure, and it handled it without a blip. So nobody had a blip, and we just left it there after that. So external websites facing external just kind of makes sense.
Yeah, I mean,
and we have
wins.
many other cloud stories, but it's the cost effectiveness of it. It's the speed to market. It's the return on attention for us of doing new experiments where a user of IT gets interested. We prototype with them very rapidly, try it. If it works, it can go into be productized. And that speed is really new for us and exciting.
That term that you just it was a throwaway term, but I want to dig into that. You said return on attention.
Return on attention. It's a term we made up.
That's a great term.
It's, if you're doing a prototype, and if you're doing something like cloud computing, which was a prototype to start, you will never get return on investment. It's the wrong thing to look for because you won't get the investment. Instead, if you get the attention from an end user who's interested, and you do this rapid prototype experiment on a real business problem, and you do it together, if you get two of those, ROA plus ROA equals ROI, because then you will get the investment and you can measure it. Speed to market is much more important initially than return on investment.
So that's effectively a formalization of fail fast.
Yeah, it is. And failure is hard in our world, but failing in IT is a big deal. I had this epiphany. It took 3 years, so I'm not so bright. I was getting frustrated because people were saying, "No, I can't do that pilot." I said, "Why can't you do the pilot?" But in their minds, pilot meant if it works, it's going to go into production. It's a big deal. In my mind, it meant if it works, that we learned something. So the right word is prototype. Once we changed the vocabulary and said, let's do a prototype and we'll learn something, it was much lighter and easier. And you don't need to overly process a prototype.
Right.
It's a big deal for us.
Prototypes are effectively meant to fail.
Yeah.
And pilots, though, if they fail, then, oh man, that pilot, I poured my heart into that thing.
That's right. It's a different amount. So we have a process, ideation, prototype, pilot, production. And between prototype and pilot is a huge difference in documentation and time, and therefore money.
It's so funny that all these years later, the most important thing in computer science is naming things correctly.
Isn't it, though?
Because it just affects how the users look at it, it affects how the engineers treat it, it affects how management deals with it.
There's another term, if I may throw out, which is kind of fun, and it's eye-catching, because I agree with you. It's the moniker. It's we have something we call the IT petting zoo. So what's a petting zoo? It's where you get to pet the animals. An IT petting zoo is where you get to try the new technology, the emerging technology that's coming in that next IT decade. And we borrowed I heard the term from Booz Allen Hamilton a long time ago, and we liked it, so it stuck. And a lot of the new things in IT first enter through the IT petting zoo, and it's about the use case. It's about somebody taking this emerging technology, trying it, and if it works in our world, then we adopt it. If it doesn't, we write down why it doesn't. So when other people try it, we can understand it. It makes a lot of economical sense, and it's exciting, and it's fun, and I have many examples of things that went through the petting zoo that we're now using, and they're fun.
That's a great term. I'm going to have to try to get that to catch on at work. We have a thing that's called the garage that people use to, and if something came out of the garage, if it succeeds, that's great. We can say, look, that's amazing. It came out of the garage. But if it failed, you say, well, it's just a little garage project. It's just something fun to try out. And it's a kind of an IT petting zoo.
Yeah. No, actually, your garage is quite impressive. And we're about to create maker spaces. And we're doing hackathons. We'll be doing maker fairs. We do a lot of open software. We're now getting into understanding open hardware and playing with it and trying it. And that enters through the petting zoo.
Every time I mention Maker Faire to someone and they don't know what it is, I just kind of die a little bit inside. But then I get really excited because I want to explain to them how important it is to go to a Maker Faire, to take their kids to a Maker Faire. Are you all looking to get more involved in Maker Faire?
Oh, very much so. So we do hackathons, right? Hackathons is software. So forgive me, I'm going to give my little definition. And
Please
it
do.
may be completely incorrect.
No, that's okay.
But hackathons
Versus Maker Faire.
Hackathons are for software. There's this new movement that a programmer of the future is very different than a programmer of the past. It's about making the data available and stringing it together very quickly. And now we're experimenting with wearable computing. And wearable computing has the ability to change our labs, has the ability to change our conference rooms. And the fact that you can be hands-free and command it with gestures or voice enables all kinds of things. So all of a sudden, you're getting hardware devices. And with open hardware like Arduino, Raspberry Pi, you can afford it. So now if you can take the passion of software and the passion of this new hardware and put it together, we can start creating things that we couldn't afford to do before. It's almost, it doesn't have to live forever or have a huge investment. You can just prototype, try it, fail quickly. And what I've found is that when we give these type of solutions to the end user at JPL, they innovate and create things that we could never dream of in IT.
Yeah, it's funny that you mentioned that. This is a bit of a non-space related thing, but it might be interesting to you thinking about wearables and open technology. I wear an insulin pump, and I have a sensor that shows my blood sugar. And this is a sensor that's made by a company that does not give us their data. It has a proprietary connector and proprietary this and that. And I've been in the industry thinking about managing blood sugar systems for 20 plus years. We, not myself, but a group created a hashtag and a project called We Are Not Waiting, We Diabetics. So I'm not going to wait for the FDA. I'm not going to wait for this company to give me their data. So we got the data out of this device. We plugged it into Raspberry Pis and Arduinos and Androids. We send our blood sugar data up into the cloud. Imagine how long it would take for us if we had a child with diabetes to wait for this product to be cloud-enabled where I could see my child's blood sugar at school. I'm not going to wait 10, 15 years for that. The child will be out of school.
That's right.
So they did it themselves. And they take this device, this small, it looks like an iPod Nano. They plug it into an Android phone. They put it in the child's backpack. And then dad or mom can watch the child's blood sugar and have a sense of well-being.
It gives me goosebumps.
It's fantastic.
It's amazing.
It's plugging these Lego pieces together in ways that, one, I shouldn't have to wait. I hope that the companies of all kinds allow us to do things like that.
Yes.
You're doing some cool stuff with Pebble?
Yes. So wearable computing, remember Jim Rinaldi, the CEO at JPL, and I saw the iPhone coming. Mm-hmm. And we got really excited about the potential for applications on the phone. This was before they really were open and all that. Mm-hmm. And it happened. Now, with a wearable computing like Pebble, what we did is we crowdsourced some of that, went out for a hackathon, and wrote some applications. Fun applications, like you can see the latest pictures from Mars on your Pebble. They come down because Curiosity landed on Mars. Mm-hmm. We wanted you to see the pictures, so we put the pictures in the cloud. Now the pictures were in the cloud, we can now just pull them down for any device. Mm-hmm. So you can see the latest pictures from Mars on any mobile device, on the Pebble, in Google Glass, etc. Another one we did was Opals. Opals is a project that is trying to do optical communication to space. The difference is right now we get all of our data through a straw. The straw is called radio frequency. Mm. If you could do optical comm, all of a sudden you get a fire hose. So you could do so much more. So this was an experiment, put essentially a laptop on the space station streamed high-definition video down to a receiving station on Earth, but do it through optical comm.
Like fiber optics without the fiber?
Fiber optic without the fiber.
So it's just a laser mirror to mirror, like straight shot?
Yep.
But the speed at which the Earth turns and the orbit, I mean, if even in geosynchronous orbit, there's going to be jitter. How do you
So you have
aim?
to tune it, and you can do fairly short, but still long enough bursts. Mm-hmm. And the data is so much faster.
Really? So I was always wondering, like, it's great that we're landing on Mars, but where's my 1080p or 4K video?
Imagine high-definition video from Mars.
4K. That's fantastic.
So, it's coming. And that was very successful. And so that optical comm was a fabulous thing. And they wanted to synchronize their watches. This was a very young team. Was part of the early career hire program that JPL does. Our leader, Charles Elachi, is an amazing man. He had this vision of getting excited young people in, and they put a lot of them to do this Opals project across NASA. Mm-hmm. And so they wanted to synchronize their watches because they had a hard time finding out when the laser firings were coming. So we created what we called an innovation vacation. An innovation vacation is a prototype where somebody could do something they're passionate about for a short amount of time because we don't have that much money.
Like Google's 20% time that they talk
Google's,
about.
That was the purpose. Could we do Google's 20% time? No, we can't afford it. What else could we do? Let's do an innovation vacation.
That's cool.
A guy named Rob Widoff at JPL and I came up with that term. So we found this person who was passionate, wanted to do something on Pebble. So great. We have this problem. We want to try to figure it out. So he did it, a person named Dan Isla, and he got a 1 week vacation from his day job. His management said, okay. And then in 1 week, he created this app. But he created it from first wanted on the Pebble, but he created it on the iPhone, the Android, the website, all in 1 week by just being 100% focused. And so we funded him for a week to do this, probably work day and night.
Yeah. Well, it's a personal sprint. Why not run as fast as you can?
And he came out learning this new technology. Everybody loved it. And it was very successful because all of a sudden, the people who were doing this were mobile. They weren't tied to their screen anymore. Mm-hmm. And there was a very interesting. So we're going to do more innovation vacations. We're doing a lot more with the Pebble. The fact that you can control devices being hands-free. And now we're also doing a lot with Google Glass, which makes you hands-free completely. So it's the use case in our clean rooms, for instance. It's important to be able to be hands-free, and especially if you have gloves on.
Are you doing anything with Connect or with...
Oh, yeah. So natural user interface, NUI. And Ops Lab at JPL is doing a lot with it. So we're partnering. We kind of use the petting zoo approach and they take it farther. Like I said, if you give something in the hands of an end user at JPL, you'll get amazing results. So JPL and Microsoft had a partner early on with Microsoft Connect. And today we're doing things like being able to zoom a model in 3D by using your gestures. Just put a Microsoft Connect on there. We're controlling robot arms remotely by tracking your hand movements. And if you can do that, maybe you could do it on the moon or in Mars. So this is a pretty big deal across NASA now. The whole wearable computing, the gestures, and it's the bottom line is we're using gaming technology, right? That you can buy in the store. So the consumer electronics is changing so quickly that all we really need to do is stay in the forefront and try to figure out what's coming and if it has any application to us. How do you know if it has application? You put it in the petting zoo, you let people try it out who are passionate end users, and they'll figure out if it's application. But another buzzword, if you will, is today's toy is tomorrow's tool.
Yeah.
And that's it. It's very true. So sometimes as CTO, I call myself Chief Toy Officer.
I know that you're interested in Google Glass, but I think that the Oculus Rift with 1080p or 4K that close to your eyes, combined with some interesting Kickstarters, like there was one that was called an Omni. I'm going to get the name wrong, but I'll put it in the show notes. It was like an Omnibox, and basically imagine the kinds of discs that kids use to slide down on a sled. It's a round disc that's concave. You put it under your feet, and you have a belt on, and you can actually walk pushing on this disc with an Oculus Rift on, plus a Kinect to know where your hands are. That means I'm walking on Mars from my perspective.
It's fabulous. So we're looking at all the use cases. So we can already, and it should be live in Google Glass now, you can be on Mars and turn around and you'll see it in 3D. When you do the same thing in Oculus Rift, you are completely immersed. And Jeff Norris' team at JPL did a lot of development with the Oculus Rift so that you are completely immersed. And that's now you can do teleoperations, tie the movement, and we also use the leap to follow your hand movements more closely.
Yeah, leap motion.
So you tie all of those things together, and you now have an amazing experience where you're on Mars and you're picking up a rock, and it's translating to movements where the robot is actually picking up a rock.
So as a consumer of the information that's being provided to me via JPL and NASA, I can do this Oculus Rift, Google Glass things today. But put me in the mission control person or the scientist are there scientists working in this industry who are going to put an Oculus Rift on and look around and do that? Or are they sitting in front of a computer with a mouse exploring I think that rock is important?
It's something we're studying carefully now. How can you drive time on Mars is expensive.
Sure.
It's not like there's a rush hour, but you only have so much time. So could we be more precise? So there's a lot of research trying to figure out how can we make more accurate decisions. All of the rover can drive itself, and it's automated. We try to plan the drive. So there's a lot of happening. So your question is very well put. So stay tuned. I think they will invent something.
I'm interested in if perhaps the consumer, myself, has more fun toys than the scientist trying to solve these problems.
That's certainly been true in the past. And we want to bring those toys into the scientists. They can use them. 3D printing is a good example. 3D printing is really coming of age. In that the IT decade, the 3 years.
Right.
6 years ago, I stupidly predicted that 3D printing was a big deal. Nobody cared.
Really?
I thought it'd come down from $100,000 to $10,000. That's such a price drop that it'll surely take off. It didn't. Now, we predicted it again, and now 3D printing is really taking off.
Yeah.
Because it went from roughly $10,000 to $1,000.
Yep.
We could now buy several 3D printers, put in the petting zoo, have people experiment. We found that it reduced the cycle time from months to hours, where the scientists and engineers can they can design models, print them, try them, even if it's in plastic, learn, print more, learn, and eventually, which is much, much faster than before, we can then 3D print it on an expensive 3D printer that either we or somebody else have, or we can manufacture it the traditional way. And it's remarkable. 3D printing we're now experimenting with, could we 3D print on Mars?
Right. So send something over there that was the raw equipment, and say, we need a little bit different part for this, or the robot is too small, let's make it an arm attachment, or
exactly
whatever, like an anteater's nose to go into a particular location.
Yeah. Or imagine that you could send this 3D printer, and of course there's radiation on Mars, so you need to build a hut. 3D printer could take the regolith of Mars, essentially the soil,
right,
and make bricks and stack up bricks. We couldn't afford to transport all those bricks up there.
You know, it's funny. I just watched this really horrible movie called Transcendence with Johnny Depp, and it was just awful. You know, and he becomes omnipotent and everything. But what was interesting about it was that he had developed nanotechnology and started taking the dirt itself to create solar panels to power himself. But the idea was that there's all this silicon in the there's this equipment, like there's this raw material. Let's just shorten the distance between I need solar panels and there's some dirt here. And he basically would, it would look like dust, and then the nanomites would turn into something. That's what you basically just described.
Yeah.
You've got all this dust. Let's make a robot.
There's certainly enough dust on Mars. The other thing about the 3D printing is materials. I think that's where the next revolution will come. You can now, so let's say you need to mate plastic and metal. That's going to be a very weak
Indeed.
link. What if you could print something that is gradually plastic and turns into metal?
Oh, because at the not the molecular level, but at the micron level, it is intermingled.
Yes.
Because you can 3D print metal, you can 3D print kinds of plastic. Why not do it at the same time?
It makes my head hurt when I think about all the possibilities. For example, a solid structure is expensive, but if you 3D print it, you can print it as a lattice works. And that's just as strong. A honeycomb is as strong as a solid, but it doesn't weigh nearly as much.
Right, a fraction of the amount.
There's a little startup out of LA called AIO Robotics that's working on an all-in-one 3D printer, copier, scanner, and fax machine. So imagine if you could fax a spare part up to the space shuttle or to Antarctica.
Right.
And for the price of this machine is probably about, I'm guessing, $2,500 or something like that.
Right.
But it's an amazing future. And so far we're really talking plastics, but once you start talking different materials, could we print a spare wheel on a rover on Mars?
That's fantastic.
Yeah, it's quite fun.
Well, thank you so much for chatting with me today, sir.
Can I give one last plug?
No, please do.
The open data. And so big data is a big deal. So the next IT decade is social mobile analytics, cloud, and key disruptors. The analytics is the actionable part to big data. Big data is overhyped. Analytics is not. So analytics means we'll need data scientists who can tell a story. So the educational system should prepare them for being tinkerers that can visualize data quickly and tell a story. And our mantra right now is to, when we do new missions and we're thinking about it, is to think data first. Think about how the data will be reused. So we have the cloud, so we can store data and we can access it. And we can do lots of computing on it. But we have to think about how we would reuse it. And now everything is data. We worked with Microsoft, for example, to be able to take the videos we produce in JPL tube. It's like a YouTube, but it's inside our firewalls. And be able to automatically transcribe them. Used something called MAVIS, Microsoft Audiovisual Information Indexing Service. And it's fabulous, because now you can search thousands of videos in a fraction of a second, and it comes back with the words the people spoke. You don't need the metadata, because it's created automatically. And so now you can reuse lessons learned, you can do all that. And then we realized once we have that, the videos are now data. You can do analysis on them, you can search for the words that are engineering videos different than safety videos, et cetera, et cetera. So everything has become data. It's an amazing new world. So thinking data first will hopefully drive us to even more exciting missions.
Some of the visualization technology that's been available, like with D3.js.
Yes, we use a lot of that.
It's mind-blowing. And I still struggle to create D3.js, quality visualizations that are as good as those that Mike Bostic and the people who know how to use D3.js. But it feels like Edward Tufte's kind of, his predictions are coming true now.
Yeah, he sure was ahead of his time. He's a hero. And I tie that to 3D printing. Imagine that we could 3D print the orbits it took to get to Mars. Tying the data to now being able to visualize it and share it and hand it around.
You know how in all the movies that are about space, there's some big round disk that all of the important captains get around, and then they have like a hologram topography of whatever mission we're trying to do. Every great sci-fi show has that visualizing disk. And I don't know if there's enough, if holograms will ever truly happen, but I saw something recently. I think it was MIT's Media Lab, but those grids of nails that kids can buy where you put your hand underneath the nails and then the nails pop up and you basically see a nail projection of your hand. The MIT media people basically had a table full of those nails, and they could not 3D print, but instantly visualize a topography or something that was happening. It would be amazing if you had that optical connection to Mars and the rover is moving. We would actually see the topography of what was happening in real time physically. Not a 3D representation as we would see it on a screen, but that topography at a table level.
I agree. And it's about that emotional connection with the data.
The visceral sense of the data.
Yes. And because for us, the 3D printing, the visualization, all that means the scientists and engineers have a much better discussion with IT, so we can take fewer missteps. It's about being able to visualize where we want to go, but then also be able to take the prototype steps rapidly to get there. It's never been a better time to be in IT. Every day is a new adventure.
Well, this has been an absolute joy, and I'm afraid I could talk to you for hours, but our time is up. Maybe you'll come on the show again sometime.
I would love to. Thank you very much, Scott.
Thank you so much, Tom Soderstrom from JPL, and this has been another episode of Hansel Minutes. We'll see you again next week.